around for 10 years or so, and we recently launched a new smart contract runtime, which is Soroban, based on WASM. And the impetus for this discussion is that with Soroban, we decided to tackle state bloat from the ground up. So, Anatoly, you've recently been posting a lot about state bloat, but Solana did have a rent concept from day one. So what didn't work about rent, and what is the motivation to try and fix this right now?
Yeah, so we thought state was going to be a problem, but we weren't sure when and where. And what seemed natural to me was that developers should be charged kind of like they do on AWS. So you have some state that you've allocated in AWS, and you typically pay for it like X dollars per gigabyte per day or per month or per year. Um, and if you stop paying for it, Amazon deletes it and gives your extra space to somebody else. Um, that idea is correct. The problem with it is that with smart contracts and immutability, it's actually kind of really painful for programmers to write software that assumes that the state could actually be destroyed um, by the system without interfacing with the program itself. Um, and writing like complex logic to handle destructors of that state and things like that and automatic hooks to go process them is also really, really complicated. So there isn't like a very clean solution. And out of necessity, we added if you want to keep your state around forever, you can like prepay for 2 years. And we kind of had this assumption that every 2 years, roughly, the cost to store it is going to drop anyway. So you're, within the ballpark of what you should be paying for it. Um, and everyone just simply used that. They they just always prepaid for the state, and nobody used rent. So rent became this kind of dumb feature that nobody used, and was a whole bunch of complexity in the code to manage it. So it got ripped out to simplify, but then you still have this problem like, well, the entire state machine is going to grow, and not even the value of the state itself, but simply the index. The number of keys that's available to the system that each validator has to know about can be arbitrarily large. So you have to figure out some solution to deal with that.
Got it. Now, the perceived ethos of Solana is basically, if when in doubt, just use a bigger machine. Does this like not hold in this case? Like, what's the limit in terms of like how big you can just like solve this with like getting bigger machines, bigger RAM?
Yeah, we haven't like needed this. It's not a fire yet. So to give you a rough idea, Solana has about 500 million accounts right now, and the snapshot is 72 gigabytes, which is totally reasonable for a modern day computer. Um, the question is, can we lower the price to allocate by a factor of 100? And the problem is that if you do that, we would expect the snapshot to grow arbitrarily large, and eventually you'd need to raise the price, right, to stop people from allocating. So you're kind of stuck in this environment where the price to allocate is a little too high for developers, too low for a motivated attacker, and you're in this like in between mode where it feels like it could be better, right? Like you really, really want to offer developers really, really low cost to allocate. And the only way to do that is then to bisect developers, right? You developers that want state that's ephemeral, they can pay a very low price, allocate it and use it and goes away. Developers that want to pay for long-term storage can pay more and persist that state. So you have to effectively, just like AWS, you have Glacier, you have object storage, you have like your on disk storage, and all those are priced differently.
Got it. So, Garand, Stellar already has a base reserve system to keep the ledger size in check. Can you explain what that base reserve system is and why for Soroban we decided to go in a different direction?
Yeah, so the on Stellar, the base reserve system is actually pretty similar to what Solana's rent used to look like. And essentially, this is our version of the prepaying for storage that Anatoly was referencing earlier. And essentially what it is that for every piece of state or every size of information, you need to keep what we call a base reserve. So it might be like a 5 XLM per account. And then if you have more accounts or larger accounts, that base reserve has to go up. And essentially what this does is the intent is that you can't spam the network with large amounts of entries because to hold that much state, you'd have to have a high base reserve and have to lock up lots of lumens. Now, the issue is in practice, this doesn't really work because one of the goals of the Stellar network is to keep fees really, really low. And when you keep fees really, really low, the base reserve is also low. And so what was found is that even though we had like this base reserve sort of prepay for state, if you will, it wasn't actually preventing the bad use cases. We still saw spam. We still saw lots of state that probably shouldn't be on the network being added just because the fees were so low that the base reserve was too low to actually make a difference. And so kind of the intention with the rent in particular is that instead of having a one-time fee, you have this reoccurring fee. And this is a lot better of a dynamic because even if the fees are relatively low, just having to pay them on a schedule essentially makes it such that the spam is much more expensive in the long term. And so with like a rent-based system, and if the fees are low, you still might be able to have a small amount of spam in the short term, but it's unlikely that the rent will be continuously paid indefinitely to keep that live on the ledger. Whereas the base reserves, you pay once, you get forever. So this is kind of fixes the issue there. And so I guess kind of getting to the weeds a little bit more, I guess, Anatoly, we kind of both came to a pretty similar high level, I think, solution when it came to the state bloat and the state expiration. And so I'm wondering if you could tell a little bit about just like the high level about how you envision state compression working on Solana. And then perhaps I can tell a little bit about Stellar. And I think once we cover kind of the shared ground, we can get into the details and talk about where we might differ.
Yeah, for sure. So to deal with this problem, we kind of had an application level solution, which was called compression. And this was first released as part of the compressed NFT standard. And it's pretty simple. Like you manage a state root that's on chain, and then you have all modifications to this root, including the data, posted in transaction payload. So if you replay the ledger, you can always replay the state root. That's now part of the application space, and you can reconstruct all the leaves. So you kind of have these secondary indices that are used for NFTs. And that means that infrastructure providers or indexers or your own full node that you're running at home, you can run the tools necessary to reconstruct all the accounts that are now in this ephemeral state. So you're kind of trading the cost to keep the state replicated in every machine that is verified in consensus with just the ledger data. And it's much, much cheaper to manage ledger storage because you're not accessing the state during consensus. It's not replicated. It's not part of like the Merkleization and all this other stuff. So you kind of end up with a ton of savings there. So this was kind of this general idea. These things have been called stateless accumulators a long time ago. Maybe you can think of them as rollups, but stateless accumulators, I think, are more accurate because you're not really moving any computation or anything like that off chain. You have all the proofs and everything as part of the ledger. But the problem that this solves is really keeping track of the data itself. So kind of moving the payload. There's a different problem that's part of the chain itself. And this is kind of weird to think about, but when you create a new account, you as a normal, user or developer or whatever, or setting up your ledger, you generate a local random number that's your secret, and that creates a public key. And if you use the correct random process to generate that that secret, your public key is guaranteed to be unique. And when you submit a transaction involving that public key, you don't really have to tell the chain or pre-register it. Just you generating that key locally guarantees that it's new and unique. And the validators have all the keys available to them. So they have this giant set of state and all the indices of all the accounts, and they can check against that set. And they know exactly that this is a new key versus this is an old key that has already been used. And that proof that this is a new key is very subtle because normally you don't think about it, but that proof is very expensive. It requires knowing the entire index of all the keys on chain. And this is where compression can't help you, because in that creation of a new account, you have to somehow validate this is a new account and you should treat it as a new account, and somebody needs to pay for allocating that key in the state, versus this is an account that's already been allocated. You can't let another user kind of steal that placeholder and potentially modify program state that business logic depends on. So this is kind of the harder, gnarlier problem that isn't solved by compression or anything like that, because compression really deals with values, with the metadata of the NFT, or even the balances in a token account, or even ownership of who owns a token account. All those things you can think of as values. But the keys and the indices of where those values are stored, you have to have a proof that something is new or something is old as kind of part of the whole transaction pipeline. And this is, I think, maybe where the approach that Stellar has taken is maybe slightly different than what I thought might work. And the idea that we had with Solana was using basically a binary trie. It's a giant set of that's organized into a Merkle tree, and it's organized in a way that, given a public key or an address, you can find a path, and you can either prove that that path is 0 or it's occupied. And when you create a new transaction, you can submit it and show that it's already occupied, and then recover that account from a cold storage, or you show that it's not occupied and you can create that account. And there's some other clever tricks that we thought of using to create accounts that are new that don't require those proofs.
I am curious about the statement you made about compression, Anatoly, which is, so if you're saying that like compression doesn't really negate the need to have sort of a solution for state bloat. If we do have a solution for state bloat, like what you propose in Avocado, or what Garand's about to talk about, do we still need compression? Because compression has it has different costs, and you need to pay more for the computation, and transactions are bigger. So do we still need this if we eventually solve state bloat?
I mean, my view is that you have bandwidth, you have compute, and all these things are priced differently at different times. And 2 years from now, the price is going to change, right? Just give the developers the tools, and they'll find the optimum spots. I think as software, my experience in writing software for 20 years is I just don't know what's going to be best in 2 years, simply because who knows, maybe bandwidth is going to get 10 times more affordable, or maybe it'll be, TSMC will go to 450 millimeter wafers, and now all of a sudden you have twice as many cores as we expected, right? So you kind of just build the tools and then see what happens. I think there's some interesting applications that are kind of unique to having applications control those routes. But it's, again, kind of really up to developers to price those resources. And this is why AWS offers you, 50 different tiers of how you want to store the data, and there's trade-offs in terms of cost and time, retrieval time.
Makes sense. Garand, I think you had so much to say about Anatoly's proposal that you actually wrote a blog post about it. Do you want to give us kind of the gist? Maybe you want to apologize to Anatoly for, I think you were using the words fundamentally flawed design.
Yeah, I think I do have some opinions about it. So I think before I get too much into the weeds, kind of at a high level, the approach is very similar, where the Stellar state archival also has uses Merkle trees to essentially prove if a piece of information has existed before. And if it has existed before, then you can retrieve the older version of that entry. Now, the primary differences are first that in the Stellar network, this isn't just for the account indexes as it is on Solana, but both the account indexes as well as the account data is stored within this Merkle structure. And then the second big difference is that instead of having one single large account trie that has all of the archived or compressed or whatever you want to call them accounts, on Stellar we have a collection of small immutable Merkle trees. And what this allows is for greater operational efficiency, where no one node has to store the entire trie of archive state. And so I think this was kind of one of my first pieces of critique was this single global account trie that I want to talk about. And I think the reason why this is potentially detrimental to the network's performance is that whenever you store all of the account state in a single trie, many of the nodes in the ecosystem have to store this. So for example, in the Solana proposal, in order to actually compress a piece of information, that is whenever an account index is run out of rent, to actually remove that from the ledger and add it to this trie, a validator needs to be storing the complete trie to begin with, and then set some sort of eviction or some compression transaction to the network. And so you still have many validators that, even with this state compression, need to store all of the archived information. And in the same vein, you have RPC nodes that, in order to restore accounts that might have been compressed, the RPC nodes, in order to provide these proofs, must also store the entire archived account index trie. And so I think, from the outside looking in, this is my question is, if you have essentially, the reason we're doing state compression or state archival to begin with is because we believe that it's too expensive operationally and efficiently to store all of these accounts. And if the solution to that requires large amounts of validators to store all the accounts and many RPC nodes to store all the accounts, I don't see where the win actually is. So I was wondering if you could speak a little bit about that as to the using one single trie instead of these sharded tries.
Yeah, the main difference is that these validators that want to do this are not. It's not required for all of them to do it as part of consensus. You can run a validator that just has the standard snapshot of the current hot accounts and processes transactions, and you can boot up and run the network this way. And if you want to earn additional rewards, you can then do this proof calculation and figure out which part of the cold account, like which part of the indices that have been frozen can actually be reclaimed, and that space can be reclaimed and given to you as a reward. And the work to do and manage the actual snapshot of the entire account state, you don't necessarily need to have that be run on a single computer. They could collaborate. They could post snapshots of this to Filecoin, for example, and share the cost of that, and then figure out how to manage the distribution of the rewards and things like that. So I'm kind of like booting this problem of dealing with the giant state to a different layer, which is more, there's more flexibility there because it's not part of the tight consensus loop.
Well, I'm not sure if it's being completely kicked to the second layer, because if I'm not mistaken with the account trie in particular, this is like a binary Merkleized trie, and then in order to add new accounts to this, you have to submit a ZK proof, essentially proving that the entries are actually expired, and then giving the proof that the root has been updated. And so, if I'm not mistaken, isn't it required to hold the entire trie in some sort of relatively fast local store? I'm not talking about all validators,
right? But that's
specifically
not
the validators.
Yep.
So the validators that are evicting stuff, they do need to store that entire trie on disk, right?
Well, like you can basically shard it, right, by just the first n bits of the keys. So if you only have enough space for like X amount of gigabytes, you could coordinate with other validators, put the snapshot on Filecoin, and your particular box just works on part of the bit space, right, that you have access to, and you only submit proofs for that. But that's kind of that like cooperation and stuff doesn't need to be part of consensus itself, right? It's not when you boot a node and you're validating transactions in the ledger, that operation is not necessary. You don't need to have the entire state. So as long as the Merkle like roots are modified in a correct way and that's verifiable, you don't really care how it's done.
So I want to push back a little bit on that second part where you said, it doesn't really matter how it's done. I think there's potentially two different parts to safety when we talk about safety in distributed systems. There's liveness, and then there's actually or when we talk about security, rather, there's liveness and there's safety. And so I agree that the design you've put forward verifies the safety of the information. We have this Merkle system such that you will never be able to put information on the network that's not legit, And I agree that the safety of the data is very much maintained, but I'm not quite sure about the liveness of the information. And I think this has to go into kind of like the developer experience and how the RPC system works as well, because in kind of the system you proposed, actually making sure the data is available is something that's kind of not the protocol's responsibility. Kind of, you mentioned it yourself, how it's kind of being kicked to a layer 2. And so I think I have a little bit of concern with being able to restore your information in this design. Because while I agree that if you know what the information was when it was live on the ledger, then you're able to restore it. But there's nothing at the protocol layer that actually helps or allows people to find the information once it's archived.
Yeah, there's not.
And so I think there's so I think, do you have any concerns from either a censorship resistance standpoint or just a developer experience standpoint on how this proposal essentially makes data availability lesser than we have today on the blockchain?
So if you don't want to deal with this risk, you can simply just pay rent, right? So that part is easy. So there's some economic cost to users that really, really care about their state. And that could be insignificant. Like if you have $1 balance on chain, the cost of rent could be insignificant to that. But oftentimes if you mint 100 million NFTs, that is significant amount of state, and you don't want to pay for all of them. So you're happy to sweep 99.59% of them into this cold storage. And the question that you raise is a really, really good question and an important one. It's like, what happens to all the leaves in those trees, and how do you recompute them? And this is something that we weren't sure was going to work with compressed NFTs, but basically it's a similar problem to long-term storage of the ledger state itself. Who needs the 300 terabytes or so of Solana data? And the difference here between consensus state and this archival is that any single archive can prove correctness. So you can pretty quickly verify that this particular ledger archive actually connects to the last Solana root that's been voted on consensus by all the nodes, and it connects to the Solana chain. You just basically check the hashes of all the blocks. That's pretty straightforward. So as soon as somebody finds that data set for you, you can quickly validate that it's correct. But you still have to have somebody store it, and you still need that retrievability to be reliable. And I don't think there's a really, really great solution out there. I think solving it specifically for state didn't seem any better than just relying on the fact that the ledger has to be backed up anyways. And there should be some commercial pressure to do that from all the users of the chain itself. So all the NFT providers, all the indexers, all the RPC people, they all want the state to exist. And as long as it's commercially important for them, then it should be available. And this is kind of similar to what Linus said about Git is that like he doesn't have a central Git repository for Linux. It's all the developers. As long as there's devs that are working on it, then there should be a copy, and any single copy can be verified to be correct. We had like actually an archiver design way back when. If you go look for like Medium articles from the original Solana kind of like 2018, 2019 era, there's this protocol for constantly checking the ledger state and running erasure codes and Merkleizing it and stuff like that. My thought is actually companies dedicated to storage, like protocols dedicated to storage, like Filecoin, are probably going to do a better job there. So the theory is that like use something like Filecoin or Arweave, and you dump snapshots and the ledger storage there, and there's some guarantees that it's going to be around and available for forever, effectively.
Well, I think there are still some issues with that though, because one of the things you mentioned that so long as the data is commercially viable or commercially available, then someone or commercially valuable, someone will make sure it's there. But I think there's lots of state that might not necessarily have commercial value on its face. So, for instance, you could have things like DAO votes or things that are not necessarily backed
Sure, but
directly to a commercial purpose.
all these state transitions are still recorded in the ledger, and the ledger itself is not going to be like partially stored. It's going to be entirely stored.
Well, why? I mean, why is the ledger not partially stored? I mean, if you have because I believe in the proposal, once the
Why
account
not?
data,
So,
because it's expensive.
so
I mean, if
it's
if
it's
storing the
not
ledger is expensive, then why would you store all of it? Why wouldn't you just store the subset of entries that actually have value?
the problem actually with it is that it's not expensive enough. Like it's like 40K, 30K to build a 1 petabyte storage, and there's only 300 terabytes of ledger. So it's too big of a pain for any individual user to store a petabyte. But it's not 100 petabytes where it's obviously scalable and commercially interesting to store it. So it's at that spot where you don't have enough of a financial reason to go build a protocol to store an exabyte of data, right? Like, so it's actually not that expensive to store the ledger. And it's not that expensive to store intermediate snapshots of the entire state on something like Filecoin, because you're not paying for, 10,000 nodes all replicating it in their like RAM effectively. What you're paying for is an archive. You only need maybe Reed Solomon 20-to-1 ratio of storage, which is going to give you infinite amount of reliability on that particular storage instance. And any single instance can prove correctness pretty quickly. So my view is that like the ledger itself is not expensive to store, and what's necessary is like the reliability of it being stored, and that just requires people that need this data set and are the users of that data set, and kind of that whole ecosystem around making sure that the data set is available.
That makes sense. We are running a bit overboard on time. There is one question that I wanted to ask both of you. I think that Garand touched on developer experience in general. And it seems like a basic premise of blockchain and one thing that developers love is that all state lives forever. And what we're doing here in both of these solutions is kind of like changing the game up a bit. And we're introducing this like new complexity. So like how do we protect developers and even to more extent like how do we protect users from like the pitfalls of state archival and having state just disappear from on chain?
I think if the alternative is that it's really expensive, developers will kind of eat complexity to save costs. So I think this is kind of like I don't think there is like a magic bullet here. That's kind of the problem with a lot of really complex globally scaled systems, is that there's no just silver bullet for a lot of stuff. So if you want to have it easy, you can pay the cost to keep your chain hot, to keep your state hot. If not, I think like it's still software developers will build tools and libraries to make it easier to deal with the complexity for the common use cases. But I don't think there's a magic solution here to completely get rid of it.
Garrett, I think you have some ideas around how to use RPC services for that.
Yeah, so I think there is some inherent complexity, but I don't think it necessarily needs to be put onto the user. I think I think rent is user facing. I mean, you have to pay rent. There's nothing to get around that. But I think if you have, at least in Stellar's design, the actual complexity of state archival is handled by the RPC instance, such that because we have this sharded, Merkle design that stores both the account state and also the account data, it's very lightweight. And this allows an RPC node, either on one node or many, many nodes, to shard the state such that you can actually provide proofs and do all of these, essentially handle the complexity of archival via the RPC simulation endpoint. So essentially all the user has to do, in addition to paying their rent, can't get around that, just whenever they simulate their transaction on the RPC can produce these proofs and things automatically. And so I think that, of course, there's some intrinsic design in the system. I don't think that, or some intrinsic complexity, I don't think that complexity necessarily needs to be pushed on to the users of the network.
Awesome. Sounds like a win-win. Okay, we're way over time. Any final remarks, any final questions for one another? Anatoly, Garand?
Great minds think alike. It's awesome to see that somebody else has had the same ideas.
Yeah, that's awesome. And I think the bottom line is that there are a lot more similarities than there are differences between these solutions. So that's pretty awesome. Thank you so much for taking your time, Anatoly, from across the ponds, and Garand. Have a great rest of your day.